So we'll now talk about Matplotlib and Seaborn. So we're moving on towards visualizing our data. So obviously when you have a data set and you want to study it, an important thing is to make sure you visualize the data, right? Different columns of the data. And so visualization is an important step in understanding the data. Your data obviously is just a bunch of numbers, right? And you can get a feeling of different variables in your data. You can look at different tendencies like the central tendency, standard deviation, mean, which we've already looked at a little bit. We'll obviously come back to that. But an even important step, because we like pictures, right? That's the reality. So we need to start looking at how to make plots of our data. And so Matplotlib and Seaborn are important libraries in Python, which are built on NumPy. And so we're going to use these to visualize our data. And so again, the first step is to import these libraries into our program if you want to use it. So the way we import these libraries is the following. So this whole, the pyplot, right, is the function in Matplotlib that we'll be using for plotting. And so we're always gonna import it as PLT. So whenever we refer to PLT, Python is going to know that we're gonna use this. And so NumPy we've already seen, and Seaborn we are always going to import as SNS. And so you can get more details on pyplot using this link. So let's look at a simple example, the simplest graph that can be, and that is a linear graph. So let's say you want to plot a straight line, a linear graph. The first step again is to import matplotlib.pyplot as PLT. So now we're going to use PLT, right, and the plot function of PLT. So any function within this class is gonna, we always use the dot, right, and then the function for this library, right. So the plot function, if you put in a list in the plot function, so this is a list of just 4 numbers, and so and then we give it some label. So plt.ylabel is going to give it the graph a ylabel. And so we're just going to call the ylabel as some numbers, and then we're going to show the graph. plt.show is the step 2, show the graph. So when you do that, now you can see that this is just, we've just given the graph or the plot function y values. So you see these 1, 2, 3, 4, right? These are the y values. Python automatically, if it just has the y value, the plot function automatically uses the indices as the x value. So we have this data point, this 1, and then we have 3, and then we have 4, right? So you can see that Python starts with 0 index, right? So this is 1 index, this is 2, this is 3. So it automatically uses the index for the x-axis. So let's go a step ahead, and let's say you're going to give it the x value. So these are the x values and these are the y values. And so now you're going to give it give the plot function an x values to plot. So instead of indices, it's going to use these values. So 1, 2, 3, 4 are going to be x values. So 1, 2, 3, 4, and the square of these is just 1, 4, 9, 16. So and you can also give the range of the axis. So this is the x range, right, and this is the y range. So y goes from 0 to 20, and x goes from 0 to 6. And so this is the y range, and then we use plt.show. And so this is the convention. The x goes first, y goes after that, and similarly for the plt.axes. You can give labels by using plt.xlabel, plt.ylabel. This RO, right, this is the type of graph that you're plotting. So this R refers to red, right? And the O refers to filled circles, right? So that's why you have these dots over here, because of the type that you have chosen over here. Now we can also just plot an empty axis. Sometimes we need that, so let's look at that. So if you want, you can so here we're just choosing a style, plt.style, that use seaborn-white grid. So that's why you see this grid. By default, this is just there's no grid over there. So I've chosen this because I like grids, but you don't have to choose this. It's just it makes the graph look better. Like you can see in the previous graphs, you could see easily read the numbers, right? So grids are good. So if you just use plt.figure, right? So in Matplotlib, we use this sometimes, where we just start the figure with a figure variable and an axis variable, and so you can see what the graph looks like. So this is just an empty grid, and so let's look at what these things actually are. So in Matplotlib, what you'll see this a lot of times, that when you want to create a figure, you use the following steps. So a figure in Matplotlib can be, you can think of it as a single container that contains a lot of objects like axes, graphs, text, and labels. Now the axis is like a bounding box, right, with tags and labels, so it has a lot of information, right? So we typically what we do is we start off with instances, and this is what we did over here also in the previous slide. We started off with these instances, and so when we create these instances, we have basically set up the setup. We have made a setup to create a figure, right? And once we create these axes, we can use the ax.plot function. And so we're gonna use convention. We're gonna name the the figure plt.figure as fig. So this is just convention, and plt.axes as ax. So again, this is just convention, but we'll stick to it. When you search OpenStax and Stack Exchange, you'll see that these conventions are followed over there also. So it's useful to follow the convention so that you can relate to stuff when you are seeking help. So we're going to use this ax.plot function to plot the graph. So here's an example. So again, we're gonna set up the stage. Yeah, that's the word I was looking for. So we're gonna set up the stage to first create the instances, the variables that we are basically gonna use to plot. So plt.figure has all the figure instances and details related to the figure, and then ax has the details related to the axis. You can think about it this way. And so we then create a linear space, numbers from 0 to 10, and 1,000 numbers between 0 and 10, and that are equally spaced. So then we use the ax.plot function, as I said over here. We use the ax.plot function, and so these are the x values, and now we're going to plot the sine function. And so np.sine, numpy has a sine function, and we're going to plot the sine values of these numbers that we're referring to x. And so you can see that our graph runs from 0 to 10. This is what we gave over here. And then the x values are numbers are basically linear. Sorry, the y values are just numbers between -1 and 1. This is the range of sine, right? Sine theta has a minimum value of -1 and a max of 1. And so this is something optional. So what happens is when you're plotting in Matplotlib, using this approach is useful. Sometimes you'll see that you have more freedom to manipulate the image by this method, by this method I mean this, setting up the stage by using fig and AX. But you don't have to always do this. Sometimes just a simple plot like this one, you can just use plt.plot and then X and then the Y values. As you can see that we have just the same figure. So we haven't used any fig or AX in this case, and we get the same plot. Now you can also use you can do more things. Here is a graph of sine along with cosine, and so I'm quite sure how the sine and cosine functions work. This cosine, they both have negative. They both have range of -1 to 1, and then cosine is 1 at 0, and so on. And so, and by default, Matplotlib is just automatically gonna assign colors to these graphs.